Today, we are going to look at linear patterns to help demonstrate and explain the process of finding an algebraic rule. This concept is expected to be mastered by the 3rd grade on the vertical alignment chart. We are going to be using and completing the Blackline Master 69 to help demonstrate this process today. We are going to look at a simple toothpick pattern. In doing this activity, we will be able to find out the amount of toothpicks in the next step, the 20th step, and then create an algebraic rule to describe this system and solve for the nth step. In order to do so, we have to understand the pattern that we have in front of us. Here is a table that describes numerically what is happening in the pattern depicted by the colored toothpicks. Square 1, or step 1, has 4 toothpicks. 1, 2, 3, 4. Step 2 has 7 toothpicks. 1, 2, 3, 4, 5, 6, 7. And step 3 has 10 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. To find how many are in the next step, you could draw it out or just add 3 like steps 1 through 3. It goes 4, 7, and 10, which shows that we are adding 3 each time. This means that step 4 would be 10 plus 3, which equals 13. Let's check our pattern by adding on 3 more orange toothpicks. 1, 2, and 3. Let's count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, the pattern is correct. This is helpful in finding the next step, but what happens when you need to find the 10th or 20th step? You could just sit there and count out plus 3, plus 3, plus 3, plus 3 until you get to the step you desire. But in order to find the 10th step, you need to know the 9th step. And in order to find the 9th step, you have to know the 8th step, and so on. In this type of rule, you need to know the one before it, which is known as recursion. The limiting thing about recursion is in order to know a particular term, you need to know the one that goes in front of it. However, once you know the algebraic rule, you can jump straight to the 20th term without knowing the one prior. So, let's try to find the rule in our pattern. If you look at the diagram we have written out, you see that step 1 has 4 sticks. We can write 4 as 1 plus 3 because we notice that there is always one base stick, which is represented as the black stick, with 3 around it. Again, notice that our base stick is present in each of the following steps. Base stick, base stick, base stick, base stick. And so on to step 2, we have our base stick plus 3 red plus 3 green. On step 3, we have our base stick plus 3 red plus 3 green and plus 3 blue. And on our last step, we have our base stick plus 3 red plus 3 green and plus 3 blue, and then we realized that we had plus 3 orange, which equals 13. So we have plus 3, and plus 3. You see that a pattern is constant by adding 3. We can abbreviate this plus 3 by saying one group of 3, or 2 groups of 3 plus 1, or 3 groups of 3 plus 1, or 1, 2, 3, 4 groups of 3 plus 1. We know that this is repeated addition, and it's also known as multiplication. So we can take out the groups of 3 phrase and replace it with 1 times 3 plus 1 equals 4, 2 times 3 plus 1 equals 7, 3 times 3 plus 1 equals 10, and 4 times 3, which equals 12, plus 1 is 13. There is a rule that shows that the number of steps we have is equal to the number of groups we have. If there are 3 squares, then there are 3 groups of 3 plus 1. So we have 3 squares, 1, 2, 3. We have our 1, and then 1 group of 3, 2 groups of 3, and 3 groups of 3. 1, 2, 3 groups of 3 plus 1 equals 10. The number of toothpicks is equal to the number of steps times 3 plus 1. We have our rule to solve for the next step, which equaled 13. We can use our rule to solve for the 20th step, and so that means the 20th step would mean 20 groups of 3 plus 1. 20 times 3 plus 1 equals 61. In order to find the nth step, we can use this rule. N, which is the number of groups of 3, plus 1. By examining this linear pattern, we have determined the algebraic rule to solve any number of steps in this pattern. We can use the algebraic rule of n times 3 plus 1. So using this algebraic rule, let's solve for step 57. We would plug 57 into our equation and substitute it for the n in the sequence, or in the equation. So 57 times 3 plus 1 equals 172 toothpicks. In doing all of this, we have explained the process of finding an algebraic rule by using linear patterns.